We're now going to show a joint and a combined variation using Newton's law of universal gravitation. Newton's law says if we have two objects that have different masses, or even the same mass, just two objects, m1, m2, and there's a line that we draw between them that is r long, then these are going to pull towards each other in such a way that they are varied directly and inversely. So for instance, the force applied on these two objects is equal to the gravitational constant times the mass of the one times the mass of the other divided by the radius squared. Well, now that we have this worked out, we also know that force is equal to mass times acceleration, which is mass times gravity if we're talking about planets and the force they pull on us. And so as we're working through this, we're going to use both of these together. There's one more thing we need to know, and that's that the gravitational constant has already been found and is equal to 6.67 times 10 to the minus 11th power, with meters cubed over kilograms second squared. And so as we have this constant, we're going to use it, and so we're going to talk about a particular problem with Mars. So let's figure out what the acceleration due to gravity is near the surface of Mars if Mars has a weight of 6.42 times 10 to the 23rd kilograms and a radius of 3,397 kilometers. Now it's really important to recognize this was in kilometers and it needs to be in meters, so this is really 3,397 followed by 30 meters radius long. So our force of a given object is equal to the gravitational constant times the mass of Mars times the mass of whatever else it is we're considering divided by the radius squared. And we're really close to the surface, that's what we care about, so the radius is going to work out for us. And we're also going to let the force be equal to the mass of the object times gravity. So what we're trying to find is gravity. So m2 times little g equals big G times m1 times m2 over r squared. Notice there's an m2 on each side, so I can divide it out. And the force of gravity is equal to the gravitational constant times the mass of Mars divided by the radius squared. So let's type that into our calculator. The gravitational is 6.67 times 10 to the negative 11. We're going to multiply that by 6.42 times 10 raised to the 23rd. And we're going to divide all of that by 3,397,123. Remember, we had to convert it to meters. But we're going to square that number. When we hit equals, we get 3.7108, or roughly, approximately equal to 3.7 meters per second squared. And so that's how we can use joint or combined variation to solve a problem. So this is the acceleration due to gravity near the surface of Mars.